Assalamualaikum, brothers and sisters.
Waalaikumsalam.
Eid Mubarak to you. Hope you enjoy your lemang. I'm waiting for Brother Saki. I think, are you in, Brother Saki? Oh. Brother Saki not in. May I help? I need help, Brother Husaini. Are you there, Brother Husaini? Brother Husaini? Brother Husaini, can you hear me? Brother Husaini? Brother Roslan, can you hear me? Brother Haziq Roslan?
Yes, sir. Yes, sir.
Okay, I need your help. I'm waiting for Ustad. It's not in.
Okay.
Do you mind to take the lead to read the dua for us?
Inshallah, Doctor.
Okay, tafadhal, Ustad.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم اللهم نور بالكتاب أبصارنا واشرح به صدورنا وصح به أبداننا واسلك به ألسنتنا وقوي به جناننا وأسرق به فهمنا وقوي به عزائمنا بحولك وقوتك فإنه لا حول ولا قوة إلا بك يا أرحم الراحمين اللهم استودعناك ما علمتنا فردده إلينا عند حاجاتنا إليه ولا تنسناه يا رب العالمين.
Amin ya rabbal alamin. Thank you, Ustad Haziq.
Welcome.
Okay, let's continue our class. Hope you enjoyed your lemang. This time we are back to work. Let's imagine Brother Ustad Haziq is holding a fleet of taxis and then operating in KL here. Yeah, Brother Haziq, you have a fleet of taxis. You have 4 taxis. Let's say this is the first taxi located in Wangsa Maju, another taxi somewhere in Kuala Lumpur, another taxi located somewhere in Petaling Jaya, another taxi located somewhere near Klang. Let's refer this taxi as taxi A, taxi B, taxi C, taxi D. And you have a control center at your office, maybe your office in Gombak. And there is a call from 4 passengers. This passenger, another one passenger in Klang, another passenger in Petaling Jaya, another passenger in Kuala Lumpur, another passenger in Wangsa Maju. Let's refer this passenger as passenger 1, passenger 2, passenger 3, passenger 4. Now, this taxi can take only one passenger, and the passenger also want only one taxi, not 2 taxis. Now the control center receives this request. Customer, there are 4 customers, and your taxis are roaming at these 4 locations. 4 locations. Now, how are you going to allocate the taxis to the passengers? Are you going to take passenger 1? You ask taxi A, take passenger 1. Taxi B,
No, too far.
no, too far. Why?
Habis minyak.
Habis minyak. So, what's the best way? Taxi A take which taxi? Which
B.
customers? Taxi A.
Nearest one.
4. Taxi A, take the nearest one. This one, right? Taxi B, nearest one. Taxi C, the nearest customer. Right? Taxi D, nearest customer. Why? Just now you said too far. So that in total, the taxi doesn't travel too far and it saves petrol. Right? So you are in the business, you want to save costs. So this is a problem, but we call it assignment problem. Assignment problem. One taxi, one customer, and one customer can only take one taxi. So assignment problems, it is a group of linear programming also. You can use this, solve this using linear programming method. No, it's 5 o'clock. Are you all hungry? Not hungry, right? Or about hungry? We are going to solve this using Hungarian methods. You remember you are hungry, you can remember this Hungarian methods to solve this assignment problem. So one person is assigned to one task or one machine, one person assigned to one machine, one task, one project, and then each task is done by one person, or each machine is operated by one person. Then the purpose is to reduce the time or the distance travel. Like just now, the taxi distance travel, reduce time, total time, and whatever it is minimizing costs. Okay, let's look. So what we are going to look at is the sum of the completion time is minimum. Just now the taxi, the sum of the travel distance is minimum, or travel time is minimum. Let's look into this example. Lee Real Estate Corporation. Andrew Johnson has been the manager of Lee Real Estate Corporations for several years. The core competency of the company is the effective utilization of the workforce. And then recently, Andrew has been contracted or is secured a contract for 3 projects. Andrew's job is to assign 3 of his people, his employees, as leaders of the 3 projects. So he has selected 3 persons by the name of Jerry, Harry, and Larry for the job. And then on the employees side, the ability and experience is not the same. So each of this person, the project completion time differ considerably from one person to another, from one employee to another. And then Andrew has estimated the project completion time by the employees in the following table. So this is the table. So if Jerry were to do project number 1, so we have the project 3 projects, project 1, project 2, project 3, 3 persons, Jerry, Harry, and Larry. If Jerry were to do project number 1, it will take 12 days. If Jerry were to do project number 2, to lead project number 2, it takes 14 days. If Jerry were to lead project number 3, it takes 8 days. For Harry, 10 days project 1, 13 days project 2, 14 days project 3. Similarly, for Larry, 70 days project 1, 20 days project 2, and 13 days project number 3. Okay, let's solve this. How to solve using Hungarian method. Okay. So Hungarian method, it is developed by Harold Kuhn many years ago, based on theories developed by a mathematician, Koenig and Echeverry, also many years ago. Then he named this Hungarian method after some mathematicians. And then the idea of Hungarian method is based on opportunity cost. That means we are trying to take the opportunity cost, take the minimum. Okay. So this is the completion time that we have just now, the table. Project 1, project 2, project 3, Jerry, Harry, Larry, these are the completion times. So what we do, we are going to have a certain method. The first step to do Hungarian method, we use what we call it row operations. Row operations. What is row operations? Row operations, we look into all this time, the completion time, row by row, row by row. We look at the minimum time here, 12, 14, 8. Look at the minimum time. Subtract this minimum time from all this one by one. So 8 minus 8, 14 minus 8, 12 minus 8. Similarly, row number 2, we look at the minimum time, 10. Then subtract this minimum from each of this. Similarly, on this one, look at the minimum and subtract each of the from each of these. Okay, let's do row operations. Row number 1. Row number 1, what's the minimum? 8. 8 is the minimum. Sub 8 minus 8. Subtract 0, right? 0. Here, 12 minus 8. 4. Okay. So what we do? 12 minus 8, 4. The second one, 14 minus 8, 6. 8 minus 8, 0. Then we do the next row here. 10, 13, 14, 10 minus 10, 13 minus 10, 14 minus 10. So we get this one. The same thing on the third row. The third row is the minimum.
13.
13. So subtract 13 from all this. 17 minus 13, 20 minus 13, 13 minus 13. So this is what we get. So this is row operations. The next step, we do column operation, column by column, the same method. We look into the minimum time here. The minimum is 0. From here, the minimum is 3, minimum is 0. Here, if minimum is 0, anything minus 0, no change. The third column, anything minus 0, no change, since 0 is the minimum. But for column project number 2, the minimum is number 3. So subtract 3 from 6, subtract 3 from 3, subtract 3 from 7. So this is what you get, 4 minus 4, 0 minus 0, 4 minus 0. Okay. This is what you got, 4 minus 0, 0 minus 0, 4 minus 0. The next one, something minus 3. 3 minus 6 minus 3, 3 minus 3, 7 minus 3. Okay, go back. 6 minus 3, 3 minus 3, 7 minus 3. So here, 0, 4, 0, the same. 0, 4, 0. And then the next step, we are going to draw, in order to find the optimal solution, we are going to draw minimum number of horizontal or vertical straight lines through the rows and or columns to cover all the zeros. So when the number of lines equal number of row or number of column, then it is optimal. If not, we have to do some adjustment. So let's pick up all the zero. This is the zero just now. 0, 0, 0, 0. And then this is 4, 3, 0, 0, 0, 4, 4, 4, 0. So this is what we have. This is the last after the column operations. Now we draw vertical or horizontal lines. So crossing the zeros, we have 2 zeros. At least it hit 2 zeros. So we are going to cross this, draw horizontal line. This is the way. One line go through the row and hitting at least 2 zeros. And then we are going to hit also another line, vertical lines, vertical lines. No more zero. So we have 2 lines. We have 2 lines. How many number of row?
3.
3. Column?
3 also.
3. So the number of lines now is not equal to the number of row or number of column. So we are not achieving the optimal solution yet. So it's not optimal. So what we are going to do next, I call it adjustment. We have to do another operations. The next operation, we choose the smallest element uncovered by the line. Okay, the smallest number, element is the number, smallest number. Here, the uncovered number, 4, 3, 4, 4. So the smallest number in here, where is the smallest number?
3.
Smallest number is 3. So we are going to subtract 3 from all this uncovered number. So 3 minus 3 will be 0. 4 minus 3 will be 1. 4 minus 3 will be 1. Here 4 minus 3 will be 1. And then at the intersection of the lines, we are going to add the minimum number just now to this number, to the number at the intersection here. So 3 plus 4, it will become 7. And then the number crossed by a single line, single line, no intersections, remain the same. 0, 0, 0, 0, remain the same. And then we are going to draw a line again. So this is after we do the adjustment. 1, 0, take note. Here 0, 0, here 4 minus 3 will be 1. 3 minus 3, 0. See, 1, 0, 1, 1. Okay. 4 minus 3, 1. 4 minus 3, 1. Here 4 plus 3, 7. 4 plus 3 is 7. And then here 0, 0, remain the same. 0, 0. Then we repeat the process by drawing vertical or horizontal lines that crosses the zeros. So let's draw the 0. You can do like this, cross. You can do vertical or horizontal that crosses the 0. Yeah, I did across. Now this 0 is 0 already crosses. You do not need to do something like this. But if I don't have the horizontal line, you can draw like that. Vertical. But since I pre-prepared this horizontal, let's remain horizontal. any more zero that is not being crossed by the line? We have one more zero here. So we do vertical line that crosses the zeros. Now we are going to check for optimality. What's the condition for optimal? Number of lines must equal number of row or number of columns. Are we optimal now?
Not yet. Yes.
Not yet. How many lines do we have?
3.
1, 2, 3.
Optimal.
3. Optimal or not? How many row?
Optimal.
Optimal. Now we reach optimality. The number of lines equal number of rows or column. Number of rows or column. 1, 2, 3. Once we reach this one, then we start assigning by picking up all the zeros. By picking up the zero, then we start assigning the job. So now one job, one project, one person, one project. So now we use logic. Look at project one project, one person. Or one person, one project. One project, one person. One person, one project. So let's assign Harry first, which we assign Harry to project number 1. If he is assigned project number 1, he cannot do other project. So he cannot do project number 2. Then Larry have 1 0 allocated to him. So now Larry do project number 3. If Larry do project number 3, he cannot do, sorry. If Larry do project number 3, Jerry cannot do project number 1. Then who do project number 2?
Jerry.
Jerry. So this is the assignment. So Jerry will do project number 2. Harry, project number 1. Larry, project number 3. So our purpose is to look into the total completion time to be minimized. So this is the assignment. Jerry, project number 2. Harry, project number 1. Larry, project number 3. And then Jerry, project number 2, it takes 14 days. Jerry, project number 2, take 14 days. 14. Harry, do project number 1, it takes 10 days. Look back at the original table. Harry, project number 1. Project number 1, it takes 10 days. And for Larry, project number 3, look back at the original table. Larry, project number 3, it takes 13 days. Then add all this, we have total time is 37 days. So the idea behind it, let's say Jerry has certain fee. That means he has, like if Jerry has consultancy fee, Harry consultancy fee, and then Larry also have some fee to be charged. We are trying to minimize the cost of this person. So the 37 days, at least we minimize the cost. Okay, we can try this using Excel. I just do quickly, I show you quickly using Excel. We set the Excel, something like this, similar to transportations. I just demonstrate to you only. Now how to solve. Go to Data tab. And then Solver. Already preset. Solve. See, the assignment is the same. Jerry, project number 2. Harry, project number 1. Larry, project number 3. Total time, 37 days. Okay, back to what we are doing. Let's look into special cases in assignment problem. We may encounter unbalanced assignment problem, or we can solve using linear programming. The Excel solver just now actually solution using linear programming. We can have alternate optimal assignment, unacceptable assignment. Okay, multiple assignment, we don't do this. We can also use maximization, but we are not going to do this. Okay, let's figure out. Now we have another person by the name of Scary. For it take 18 days to do project 1, 21 days project number 2, 16 days project number 3. How many person now?
4.
4. How many project?
3.
3. So project is more than person is more than project. So situation like this, we have to balance it. It must be equal. Number of person must equal number of project. So what do we do? Introduce
Dummy project.
Dummy project. So this is an unbalanced assignment. When we introduce dummy, the time to complete is 0, 0, 0, 0. Let's imagine after we do the solution, this is the assignment. It means Harry do project number 1, Jerry do project number 2, Larry do project number 3, Scary do project dummy. Out of this 4 person, who can shake leg? Who can stay in the office and play computer game?
Scary.
Scary. Why? He doesn't have any assignment. Because assignment to dummy is fictitious assignment. This is fictitious assignment. So out of the 4 person, who can I assign to, say, administrative job in the office, not doing the project? Who can I assign administrative work between Jerry, Harry, Larry, Scary?
Harry.
Scary, right? Scary can be assigned to other function in the office. Let's look at another scenario. Let's say we have 4th project. If Jerry were to do project number 4, it will take 13 days. Harry will take 16 days. Larry will take 17 days. Now, how many person? How many project?
3 person.
3 person. 4 project. What do you see? What do you observe? Project is more than person. Project is more than person. So this is also unbalanced. What do we do?
Create
dummy person. Create dummy person. And then when we create dummy, what will be the time to complete?
All 0.
All 0. 0, 0, 0. Let's say we assign Harry project number 1, Jerry project number 2, Larry project number 4, and dummy project, Larry project number 3, dummy project number 4. Which project don't have anybody doing it?
Project 4.
project number 4. So I put another questions. Which project can I outsource to another party other than this Jerry, Harry, and Larry? Which project? Project 4 can be outsourced because nobody do. Because dummy is fictitious person, cannot do. Okay, we can also have situation like this, where we have 0, 0, 0, 0 after you do the solution. Then we can have Jerry do this one, and then Harry do project number 2, or Harry do project number 1, Jerry do project number 2, Larry do project number 3. So situation like this, we can have alternate optimal solutions. It means either Jerry or Harry do project number 1, either Jerry or Harry do project number 2. Okay, let's say this way. If Jerry were to do project number 1, he cannot do project number 2, and then Harry cannot do project number 1, he will do project number 2. Larry only do project number 3. This scenario, Jerry do number 1, Harry do number 2. Another alternative, Harry do number 1, and then Jerry do number 2, and Larry still number 3. So this one alternate optimal solution. And then we have another scenario, unacceptable assignment. Let's say we don't allow Jerry to do project number 3. Let's say Jerry not allowed to do project number 3. So what we do is we assign a very expensive, a very long time for him to complete, very large magnitude of number. So we put a symbol M. Yeah. M represent large magnitude of days or number, days or time, whatever. So when you try to solve this, this will be a very large number. Okay, I think that's about it. But class not over yet. Okay, let's have fun. Let's look into this scenario. I think it's very easy. MS consultant has received 4 consultancy works for the East Coast Development Corridor. And then the executive director is planning to assign the job to 4 of the senior consultants to lead each job so that the total completion time is minimized. The time frame in weeks for each of the consultants to complete each job is tabulated in the table here. So the lead consultant will be Ahmad, Badrul, Chaudhry, Delilah. And the job, geological study, environmental study, social study, traffic study. And this will be the completion time to do the job in weeks. And then this person, the fee, the consultant fee is expensive. And then we try to minimize the total cost. So you have been given the task to assist the executive director to plan the job assignments. Find the optimal solution using Hungarian method so that the total completion time is minimized. Then you have to state the optimal assignment and then total completion time. So this is past paper. It should be easy. Okay, shall we? You have to take your piece of paper, we do together. Okay, this is what we have. What do we do? Step number 1, row operation, remember?
Yes.
Row operation. So let's say, let's write this one. Job. Ahmad, Badrul, Chaudhry, Delilah. And then geological study, environmental study, social study, traffic study. Row operations. Remember how to do row operations?
Minus
Look.
with minimum.
Okay, minus the minimum, row by row. We take the minimum, row by row. What is the first row? Minimum?
10.
10. So 10 minus 10. 10 minus 10. What do we get? 0. Right here. 14 minus 4. 6. 3. Okay, good. The next one, where's the minimum?
12.
12. So 12 minus 12.
0.
0. 13 minus 12.
3.
13 minus 12.
1.
1.
1. 15 minus 3, or rather is saying what this one. 12 minus 12, 0. And then Chaudhry, minimum?
9.
9. So 9 minus 9, 0. 12
3.
minus 9, 3.
3.
3 also. 2.
2.
Okay, now the next one, minimum?
14.
14. 14 minus 14?
0.
0. Good.
2.
2.
2,
4.
4,
2.
2. So we are done with row operations. Let's do, what's the next one?
Column operation.
Column operation. Column operation. We have to repeat that. Column operations. So A, B, C, D. Let me write down geological study, environmental study, social study, traffic study. So the first column, all 0. 0 minus 0? 0. 0. Agree?
0. Yes.
0.
Okay.
The next one?
1.
1.
1 is the lowest. So 4 minus 1?
3.
3.
0.
1 minus 0. And 3 minus 1, 2. 2 minus 1, 1. Then 6.
3.
3.
3. Now you're okay. 0,
0.
0,
1.
1. The third one?
2.
0.
The minimum is 0.
Sorry, 2.
Minimum is 0. So 3 minus 0?
3.
3.
3.
0.
0.
2. 2.
To remain the same. So we are done with row operations, column operations. The next step we are going to do to draw vertical or horizontal lines that crosses the zeros. we are going to draw vertical or horizontal lines that crosses the zero. Now, which one to this one? Can we do vertical like
Yeah.
this? And this one
Yes.
across? Okay.
Yeah.
Let's draw the line. We draw a line that crosses the zeros. Then we draw this line that crosses the zero. We have one more here,
Yes.
and we have a gang here. Do you have a gang here? You have an option. You can draw vertical or horizontal, not both. That means minimum number of horizontal, sorry, minimum number of horizontal or vertical lines. Now, which one do you like? Across or down? You can choose. I draw
Across.
for you. Across. Across. Okay. You have done across like this. That means all the zero have been hit by the line. You do not need to draw this anymore. Okay. Yeah. This one already hit. This is already hit. No need to draw anymore. Of course, this one no partner. No partner. Cannot do. Now, how many lines?
4. It's sorry,
Four.
3.
Three lines. 3 lines. Optimal or not?
No.
Not
No,
yet.
no, not yet. So what is the next thing to do? I call it adjust. To make life simple, adjust. So let's do some adjustment. And change. I use back red color. Drew the adjustment. A, B, C, D. Geological study, environmental study, social study, traffic study. Okay, how do we adjust? Okay, let's look at the remaining uncovered number. 3, 3, 3, 1, 1, 2. Uncovered number. What do we have to do? Choose the minimum of the uncovered number.
1.
1. So okay, before that I forgot to mention. Okay, now continue. So this is 1, 1. So 1 minus 1?
0.
0. Let's write this one first. This is D to E, 0, 0. Then the
1.
1. Then at the top there, 3
2.
minus 1,
2,
2,
2.
2, 2. And then at the intersections of the line,
At
what do we do?
1.
Add the minimum number, 1. So at the intersection, add 1. So become 1 and 1.
1.
1 here, 1 here. Then the others that's being hit by a single line remain the same. This one remain the same. So it remain the same. So 0 here, 0, 0, 0, 2, 0, 2, here is 0. Agree?
Yes.
Yes. So this is, I call it adjustment. Now you proceed, draw lines again. How do you like to draw the line? Can we draw vertical here? Because you cannot do a cross, no gang here, no partner. In at least one pair of 0.
Horizontal.
Horizontal cannot, brother, because we need vertical. So at least one pair, at least it hit 2 zeros, 820. The next one, either you do this way or across. Which one do you like? Across? Across. Okay, you just do across. Draw cross. Then next one,
Across D.
D across. Okay, D across. That's my looking for my cursor. D across. Then we have one more zero here. We cannot do across because no partner.
Vertical.
Vertical. Draw vertical.
Optimal.
Optimal. How do you know optimal?
Because the minimum number of
Lines. We
lines.
have minimum number of lines. We have 4 lines. 1, 2, 3, 4. 4 lines equal number of row or number of column. So optimal. That's the reason I said just now. If you don't hit this one another time, otherwise it gives you the impression it is optimal, and then you get stuck. You cannot assign. Okay, now optimal. Let's do the assignment. Okay, let's do the assignment. One job, one person. One person, one job. Let's choose one job, one person, one job first. Chaudhry can do which job?
Job 3.
Job 3, social study. Where is it? Social studies. So we assign Chaudhry number 3. Since given this one, cannot do this one and cannot do this one. And now, who do you want to assign? One job, one person. Now you look at traffic study. Who can do?
Geological study to Ahmad.
Okay, look at 1 first. Just now I look into here 1. Now traffic study. Here we have 2 person can. Here 2 person can do. Let's look into traffic study. Only 1 person can do, right? Badrul. So Badrul assign here, and then nobody can do. 1 person, 1 job. 1 job, 1 person. And now environmental.
Environmental to Delilah.
Delilah do environmental, cannot do
Cannot do geostudy.
geological study. So who do geological study?
Ahmad.
Ahmad. So this is the assignment. So state the assignment. You look back at the questions just now.
Ahmad do geological
Yes,
study.
state the optimal assignment. That means we have to specify. Very simple. We can do just a short form. Ahmad do geological study, and then Badrul do traffic study. Then Chaudhry do social study, and then Delilah do environmental study. And then the completion time.
10 plus 12 plus
So
12
we do
plus 16.
okay, 10 Badrul to
12.
Here is 12. Then Chaudhry 12 also. 12. And then Delilah 16 days. So imagine if each week the fee is 1,000, so we have to try to minimize. So total 50
hours.
I think here weeks.
Weeks. Sorry, correct.
Weeks. So this is the answer. You look back at the question here. Total completion time. So you get 7 mark already. So 7 mark. Okay, let's try one more. Are we okay? This is very easy, right? Brother Ashraf, Peanut, sisters, brothers. Okay, let's do another question. This is easy. If there is in the exam, you should do this one first. Let's do the next question. Now, I think this is Brother Hazik's taxi operations. A dispatcher, yeah, your taxi. A dispatcher for Gombak Taxi Limited has 5 taxis at different locations and 4 customers who have called for service. The distance in kilometer from each taxi's present location to each customer are shown in the following table. And then the recent rising fuel cost requires the company to be more prudent in assigning the taxi cabs to each customer. So this is the taxi A, B, C, D. We have 4 customers. Customer 1, 2, 3, 4. Use Hungarian methods. Determine the optimal assignment that will minimize the total distance traveled and state the total distance from the assignments. So these are the distance traveled from A to customer 1, A to customer 2. These are the distance. This is the distance. So you want to save your petrol, try to minimize the distance. Okay, let's look into this one. Brother Haziq, how many taxis do you have?
4.
5 taxis. 5 taxis. How many customers request? 4. So, any observations?
Dummy customer.
Dummy. So, let me mute you all first. Now you cannot speak to me. Now can you talk? Can you say something? I just want to check whether. Oh, okay. Because just now I mute everybody. I hear some interference. Okay. Look back at this one. How many taxis, Brother Haziq, do you have?
5.
5. How many customers?
4.
4. Any observations?
Number of customer.
Dummy.
Dummy. So number of customer less than the number of taxis. So what do? You have to create dummy. What dummy?
Customer.
Dummy customer. You have to create dummy customer. So create dummy customer times 0. So let's do the process. Row operation. Do you want to do row operations? If I were to do row operations, which minimum cost should I use?
0.
0. So that means this 0 is useful because in the past some students mistakenly, once introduce dummy, they ignore this one and then they start looking 2 as the minimum cost, 1 the minimum. That's not the right way. 0 must be considered. So if you do row operations, you think this number change or you want to do another table?
Same.
Same, right? So I skip row operations. Okay. Can we skip row operations?
Yes.
Because it's already there. We skip row operations. The next one, let's do the column operations. Column operations. Column operations. So let's see A, B, C, D, E. Okay, now column operations. What's the first number? 1,
1, 2, 3.
4 dummy. Okay, I wait for your response. 7 minus
2, 5,
7 minus 2, so 5,
3,
3,
3,
6,
6,
0,
0,
1,
1. Okay, next one.
1,
1,
0,
0,
6,
106,
4,
4,
2,
2. Okay, good. This one,
2,
2,
3,
3,
4,
4,
0,
0,
3.
3. Great. Yeah,
6,
6.
2,
Yeah, 2,
2, 1,
1,
0,
0,
4.
4. Because this one 0, 0,
All
0, 0, 0. Okay, let's draw lines. We are done with row operation, column operations. Now draw vertical or horizontal line that crosses the zeros. Can we draw vertical at dummy here? Can we draw
Yes.
the here
Yes.
vertical? Okay, now we draw vertical line that crosses all the zeros. Any more that can cross?
across B.
B. B across or vertical?
Across.
Across. There's no gang. So draw across.
Across D.
E. So across. So all the zeros have been hit by the line.
Yes. But not yet optimal.
Not optimal. How do you know not optimal? The number of
The
lines is 3, not equal number of row or number of column. So what do we do? Adjust, right? Adjust. I use the word adjust. So let's do the adjustment. Draw again. Okay. I use red also. You have to draw every time. Oop. A, B, C, D, E. Customer 1, customer 2, customer 3, customer 4, and dummy customer. Okay. What's the lowest number?
1.
1. So 1 minus 1. So all the remaining uncovered number, subtract minus 1. So So the first one will be
4,
4,
0,
0,
1,
1,
5,
5. Okay, just look into the uncovered number. So the next one,
5,
5,
0,
5,
3,
3,
0,
0. And the last row,
0,
0,
0,
1,
1,
1,
2,
2,
3.
3. Okay, which one to add?
At the
the
intersection.
intersection.
B to dummy, right? At the intersection here. We have to add what number?
Number 1.
Number
Lower.
1. So we add here. Yeah, 1. And here, 1. Then the others remain the same.
Same.
The others remain the same. Here, 3, 0,
2,
3, 2.
2,
Then up here, 0.
2,
Here, 0. Okay,
0,
then 0,
4,
4,
0,
0,
0.
0. And then the last one also 0.
0.
Okay, now what?
Vertical dummy.
Draw line or vertical dummy. You want vertical line? Okay, draw vertical line. Okay, everybody agree?
Yes.
I draw a vertical line here that crosses the zeros. Any more?
Vertical 4.
Vertical here. This one.
No. For the 4 column.
Yeah. For
The
for the
column
4
Oh,
column.
column 4. Vertical column 4. Vertical column 4.
Vertical column 2.
Number 2.
Vertical column 2. So can, doesn't matter. Vertical column 2. Any
And
more?
vertical column 1.
Vertical
Vertical column 1
across D.
across
Then
D.
across optimal.
How many lines?
5.
5. How many row? How many columns?
5.
5.
5. Okay, before we discuss anything, there is also another way. You can draw the line here across also can. So this one is okay. This one across also okay. So now let's do the assignment. So where to start? Look at one. There is any one person, one taxi, one person, one taxi, one customer, one taxi. Look at B. Can you see taxi B? Taxi B can only serve one customer, right?
Yes.
Yes, let's this one use logic. There's no rule to it. Use your observations.
Taxi B to customer 2.
B to customer 2. B to customer 2. Then that means A cannot serve customer 2. Then
Taxi A for dummy.
A give to dummy. And then
No.
okay, cannot do this one, cannot do this one. One person, one job, one person. One taxi, one customer, one taxi.
Customer number 4.
Customer number 4, who?
Taxi. Taxi
So,
C.
taxi C. So cannot, taxi D cannot take customer 4.
Taxi E serve customer number 1.
Taxi E, customer 1. Then
And then
cannot
customer
do this one. Customer D, taxi D,
D serve customer number 3.
number
Number
3.
3.
So now the assignment will be
Taxi dummy
see, looking for my cursor. A to dummy. Let's see B
2,
to customer 2.
customer 2,
Let's see C
customer
to customer 4. Let's see
taxi,
D,
customer 3,
customer 3. Let's
taxi,
see E
customer 1.
to customer 1. Total distance travel
0 plus 1 plus
0, 1,
11.
1
1, C to 4, C to 4, 5, D to
2,
3, 2.
2,
2.
3,
So, yeah,
3,
2, the 3. So total distance travel
11.
11.
11 kilometer. So save your petrol. Now, which of Brother Hazik's taxi driver can go under the tree and take a nap?
taxi A.
Huh? Taxi
Taxi.
A. Why? Why, Brother Hazik? No customer. No customer. No customer. That means taxi A can be assigned for special task on that moment. Maybe to deliver some food for me. Okay, you get the idea?
Yeah.
So okay, we are done. Any question? We are done for assignment. That's all. Very easy job.
Sir,
Yeah.
what if the minimum line cross or 0 is more than the number of column or row?
Then you may overdraw the line. Like situation like this. Situation like this, you overdraw the line. That means you may have extra line like this. Let me show you. There are situations here because you see this 0, you see this is 0, you hit another line like this. So actually this is redundant because this 0 already being hit, this is being hit. So this line is redundant. So it is not likely to happen unless there's a redundant line there. Like here, you can draw across, but this line no longer necessary because this 0 is already hit by the line. It's already hit by the line. Okay, let's look at the previous one. What we did just now. You see this one? You can hit another line here. But this line is redundant because this 0 is already hit by the line. So you may feel, let's say I draw now. Let's say I happen to where's my cursor? Say I draw a line here. Wow, happy. I have 4 lines. Wow, optimal. But actually not optimal. Try assign, you cannot assign. So the reason is actually this line, this vertical line is redundant because this one already hit. So situation like this, it can give you the wrong impression. You may think you optimal, but actually it's not. Okay.
Understood that.
Understood.
Thank you.
Okay. I think we release early today. Shall we? Shall we release? Okay, brothers, thank you very much. Let's end our day with the recitation of Suratul As. Bismillahirrahmanirrahim. Wal as innal insana Thank you very much, brothers and sisters. See you again next week.
Thank you, sir.
Assalamualaikum warahmatullah. Yeah, welcome.
Thank you, Doctor.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Welcome. Yeah. Waalaikumsalam.
Hari Raya, Doctor.
Selamat Raya.
Selamat Raya, Doctor.
Selamat Raya. Thank you so much.
Thank you, Doctor.
Welcome. Okay. Assalamualaikum. I end the meeting now.